All right, I am now on page 420, and we're looking at solving special linear systems by substitution. Okay, I think it's just easier if we go into this and you'll see kind of what they mean by special systems. Okay, so this first one, x plus y equals 4, negative x minus y equals 6. So you have two equations for lines. You need to solve one of them for x. It really doesn't matter which one. So they solved this one for x. So x is equivalent to negative y plus 4. So negative y plus 4 goes in to the second equation where x was, okay? Negative y plus 4 goes in here for x, okay? So negative x, negative, and x is all of this, minus y equals 6. But when you do that, you get a negative times a negative. That's a positive y. That's minus y. Y minus y is no y's anymore. And then negative times 4, this is negative 4. So you have no more variables at all, and you have a statement that says negative 4 is equal to 6. And that's not true, okay? So if you get something like this, and the resulting equation is false, that means that the system has no solutions at all, okay? And if you look at the graphing situation, you'll notice that it's because the lines are parallel. They're never going to cross, okay? All right, down here. It looks like this is pointing towards this situation for this second one, but I don't think that's the case. Okay, let's look at another special situation. X minus 3y is 6, 4x minus 12y is 24. In order to do this by substitution, I'm going to use this one because it looks like an easier equation. I'm going to rearrange this for x, so I get x is equal to 3y plus 6. I'm going to take 3y plus 6, because that's what x is equivalent to. I'm going to take this and plug it in for x. So I get this over here, 4 times 3y plus 6 minus 12y equals 24. Okay, do the distributive property. Here's what I get. 24y plus 24 minus 24y equals 24. Okay, and when I do that, the y's completely cancel, and I get 24 is equal to 24. Well, 24 equals 24, that is a true statement. And I have no more variables, okay? So basically, that means whatever your x and y, or y is going to be, you're going to get a true statement. So if you wind up eliminating a variable and you get a true statement, then you're going to have an infinite number of solutions, because basically what they're telling you is the lines are the same line in disguise, okay? So up here, you eliminate all the variables and you get a false statement, then you have no solution. The lines are never going to cross. If you eliminate all the variables and you get a true statement, then basically the lines are sitting one on top of each other, and they're going to have an infinite number of solutions, okay? All right, so here's two more just as an example. These are already worked for you, but they're the same sort of situation. What I did is I took the second equation and solved it for x. Substituted that in where it says x. Okay, did the distributive property, did a little math, and you get negative 28 is equal to negative 28. Notice that there are no variables anymore, but I get a true statement. So this has an infinite number of solutions. These are really the same lines sitting one on top of each other. Over here, I took this second equation, I took the first equation and solved it for y. So y is equal to 3x plus 12. So this is what y is equal to. So take this whole thing and cram it in there where it says y. So we're going to say 6x minus 2y equals 18. Do some math, and you wind up with a statement that says negative 24 is not equal to 18. So because I've eliminated all my variables and I get a false statement, there are no solutions to this one, meaning that these are probably parallel lines that are never going to cross.